So, good afternoon, good morning, good night, wherever you are. Welcome to my presentation about some key object-oriented concepts, factories, services, inheritance, and delegation. I hope throughout the talk it becomes clear why I've used those in combination and did not focus on others. Let me briefly introduce myself. Mike Fechner from Consultingwerk. We are supporting open edge developers, mostly during modernization. We're located here in Cologne in Germany with colleagues working out of subsidiaries in the UK and Romania, and two colleagues working from home office in the Netherlands. From there, we're providing service to customers almost all around the world. We're a vendor of developer tools and consulting services. There are a couple of areas that we have specialized in. GUI for .NET is probably for long an area where we've been referred to as the go-to guys. Angular for web application that then leads to software architecture or application integration, and that's what we use then typically in modernization projects. The smart component library that we provide to our customers and use it a lot in our modernization projects. Couple of the concepts that I'll be explaining here, I'll show that on samples from the smart component library. We do have some of the source code available open source, so I may every now and then refer to the smart component library for something. The developer framework provides lots of for architecture of modern applications following the open edge component specification. It's truly oriented. I simply believe that object orientation is a way to write well-maintainable business applications. We provide user interface flexibility. We started on the GUI for have equally web applications based on Angular or mobile applications based on native, and of course the mix of these three. More and more important are RESTful services that can be built very easily around business entities in the framework. Yeah, I'm going to show more about the smart component library in the session tomorrow. A bit about myself. So besides being the director of Consultingwerk, I'm supporting our customers as an architect in modernization projects. But I'm also working as the product manager, architect, and developer on our framework products, Smart Component Library and the WinKit. Over the time, I believe I've specialized in object orientation, software architectures, and desktop user interfaces, and I, know enough to ask dangerous questions about web technologies. My personal background is I have progress experience, over 30 years, I think 31 now. I started writing 4GL applications at that time. When I was 16, I started working in summer vacation for the company of my brother, and they were just an open edge user. Progress version 5 at that time, and ever since then I've continued writing open edge. And before that, I've been programming in BASIC on the Schneider CPC 464. Progress was procedural at that time. When I went to the IT university in Aachen, that was before Java became the standard for universities. I had to write all the university code in Modulo 2, which I hated. It's the derived version of Pascal, but never made it, for good reasons, into real application development. What I want to say with that is I never learned object orientation as my first way of programming. I started as a procedural programmer too. My first experience with object orientation was beginning of the millennium, probably 2001, 2002, with the first version of the .NET framework. I liked that. I liked writing in C#, but if I now look at some of my very first, programs that I wrote in C#, that's procedural thinking in C# classes. I mean, you can do that. I did that. So turning into somebody who thinks more in OO concept, that took years. And it took more Progress OO language. It took, well, reading lots of blogs, going to non-progress visit a .NET developer conference, because .NET and OpenEdge are relatively similar. The tools may be a little bit more shiny, but the language, C#, what you do there, and OpenEdge, it's similar. Yes, there's some which we don't have in OpenEdge, like generics and fully dynamic types and all that stuff, but the way how you would model object-oriented application are very similar. So that's where I usually try to get my inspiration. I've never warmed up with Java, even though Java is very similar to C#. I mean, C# is a clone of Java. I can read Java code, I understand what it does. But when I have to write non-OpenEdge code, my second language of choice would be C#. And so that's where a lot of my influence on object orientation came from. Somebody who knows Java and the .NET framework would probably also recognize it on how I call certain things. I speak of lists and dictionaries. That's how they're called in .NET. In the Java world, you'd be talking about sets and whatsoever. And so that was not my first exposure to these things. I'm going to talk about the service manager. In the .NET framework, it's called the service container. So when I designed a similar class in code for our framework, I called it service container. 10 years later, together with Peter and others, we had to agree on a name, and well, they've been more influenced by Java. So in the common component specification, the service container is called service manager. It's the same concept, but depending on where it came from, the things have different names. And so with this, I have really a lot of understanding of developers that had 10, 20, 30 years of procedural progress experience, and now getting completely confused with some of these object-oriented concepts. Yeah, well, I'm still sometimes confused myself. So let's look into the agenda for the talk. So I'm going to start talking about an intro, why I'm speaking about these 4 topics here, and then I cover the topics one after the other. And I think the whole talk kind of like migrates into then, which I will code together. So you can shout if I shall code it in a certain way or different way. Yeah, talk about how to develop a small business component, business application component that would be certain OO thinking. And yeah, so I said, in order to understand object orientation, you need to do more than just learning the progress documentation. In progress documentation, you quickly find out how to write a class, how to write methods and properties, maybe also how to do inheritance, but not necessarily what to use it for. Best practices around that. So like I started in my first C# sample, and probably also years ago when the first OO version of Progress were available, I did that too. You can produce wonderful spaghetti code in classes. So then you can say, hey, I have a class, I'm an OO programmer, but it's sort the mindset. So you need to start thinking in a couple of things. And I always say a developer that when he starts writing a class, first thinks about interfaces. He's on a good way. Because interfaces are one of these key components that make OO flexible and maintainable and yeah, future-proof. So good news, you may hear modeling and concepts and patterns. You don't need to fully understand UML to do any of this. When I write drafts of object relations on a piece of paper on a whiteboard, I usually don't follow the full UML standards notation. I make it, yeah, just in a way that helps me in the moment of writing. A couple of definitions. I use that at the beginning of many of my object-oriented presentations. You may have seen that before. Types. A type is a key concept. When we create a class or an interface on enum, we create something that can be used as a data type in a defined variable statement. So it's a type. Java, the term class may be more popular. In the .NET world, it's the term type. And OpenEdge, the terms used in OpenEdge object orientation, they sometimes look a bit at Java, a bit at .NET, and so sometimes gets confusing. The using statements in progress are a little bit more like the import statement in Java, but a lot of the other stuff is more like in C#. So there's little nuances there. Strong typing is a concept that when you have these types and the compiler, and then the runtime knows about which properties and methods are available on a certain type, the compiler will validate that. So it is, unless you're using dynamic invocation, it is not easy to write code that compiles but doesn't run, because the compiler can check more. So with internal procedures of a .p file, the compiler will not check for internal procedures, and it will not check for the parameters. The compiler is able to do that. The thing that's then with strong typing are the members of a type. So members, all the stuff implemented in it. So methods, properties, events, variables, etc. Member is just the collection term for those. A very powerful concept can be access control. So for all these members, you can define whether they're publicly protected or private available. Private available means you can only use them within the class. Publicly means you can use them from any consumer of the class. And protected means you need to inherit from it to be able to call that. Now in more of OpenEdge, I don't know whether it was introduced in 12.2 or 12.0, you have package private and package protected, which means classes in a certain package, so in a certain subfolder, have access to certain things. That's something that if you think of being either a framework provider like we or the lead developer in a team that builds a system of classes in one package, and you say, hey, these classes should be able to call into each other's methods to do what they're supposed to do, but I don't want somebody else to call into that. Why would I not want that? Not because I'm not in the mood of giving him access to that for being nasty to him or whatever, but if any other developer within your organization or customers, so maybe you deliver the source code of an ERP system and you have developers at the customer side that can build extensions to that. Everything which is public, you should be afraid that somebody calls into it. And if you change it, remove it, add another parameter, the code of your callers will no longer compile. So everything which you ever made public needs to remain public forever. So therefore, specify very granular who's allowed to call into what is very, very helpful. So a class is the typical type to start with. It's a class with executable code. An abstract class is also a class that can contain executable code, but you can't create an instance of an abstract class directly. You need to inherit from it. So if we would be abusing the term include files for the code base class, because that's a way of reusing code, an abstract class is really like an include file that cannot be used by itself, where a class that you can inherit from can be used by itself, but you can also inherit from. So it's a different concept. So an abstract class is basically a non-complete class. The base class for our business entities, and I'll be showing that in a couple of minutes, is an abstract base class, because that base class by itself has no purpose. It's just providing a starting point for others to create business entities with actual logic in it. Interfaces are types that only provide requirements for other classes. An interface provides a shared type, so a subset of all the classes. You can say all the classes that implement a certain functionality, like being able to be serialized, for instance. And the enforces that when you build a class that says I'm implementing the interface, that all the methods that are required by the interfaces are actually implemented. An enum is basically that's strong typed. Typically enum might be weekdays. There will always ever be 7 weekdays. And you could say Monday is 1, Tuesday 2, Wednesday 3, and so on and so on. And then have something that the compiler can check if it's valid before you execute code, that no developer ever misspells a weekday in the source code, for instance. So why are we doing that? Ability when we write code. So the implementations, so the code right, might need to be swapped. So you should see a big application as a collection of many swappable components. So, and probably in ERP systems or in applications, would be a class that implements the price calculation. And probably everybody who ships ERP system has experienced that some customers have a different rule for price calculation. You could have lots of ifs and else and parameter tables and blah, 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 which makes it undebuggable. But if in the end, customer just has like 5 conditions, there's so many different combinations of it, it would be more maintainable, more testable if you have just the rules that you need in a certain price calculation. But then everything else, price calculation is code, probably a fraction of a % of the lines of code should know how to call into that. So that's what I mean with being swappable. That's also then useful for unit testing. For unit testing that calls into the price calculation, it might not be desired to have to provide data in a database so that you get the right price in the end. So with price tables and discount tables and whatever. Maybe you just a simulation of the price calculation table that you call into customer X, date Y, quantity Z, and what is the price. And it just always returns 42 without any parameters. Because then you know that your order processing works independently from providing data in a database that's the price calculation actually. So do you hear me good? Okay. Good. Sorry for that. And then this also means that you might, to grow your team or to utilize external developers, that you need to plan for certain extensibility and modularity and have contracts between those. So, and a common term that, well, when I started with object orientation was not just confusing, it was a bit more like annoying, always pattern. And I felt like, hey, I'm a programmer for decades too, so why do I need somebody else to give me a pattern and tell me you should do it that way? Because then, well, with patterns, you utilize experience of previous developers or architects. But that's helping you. If you follow certain patterns, then other developers that later have to deal with your code should also have an easier entry point into your code. So these patterns are actually very useful, even though they were annoying in the beginning. And principles. Patterns are more like really how do you build code, and principles are more like high-level thinking. And a set of principles that really have proven to be useful are the so-called solid principles. The term coined by Robert C. Martin, also known as Uncle Bob, the guy who also made the Boy Scout rule popular. So he's an evangelist for object-oriented design, but also for agile development techniques. Said, well, the solid principles, so which stands for single responsibility, open closed, the Liskov substitution, interface segregation, and dependency inversion. And if you ask in a group of experienced OO developers, they will all tell you, oh, I know solid and I'm writing solid principles. Not all of them will be able to name you them. I mean, naming them is also less important than applying to them. So what is the single responsibility principle? There are many definitions and they're all probably saying the same. You should try to design a class or a method or a whole module in a way that there's only one reason to change the class, and that reason would be a changed business requirement or changed architectural requirement or whatever, change in technology. If a class does too much, then you just increase the number of cases when you need to change it, and every change is a risk. With every change, you increase the risk of breaking code that was previously working. So single responsibility also makes it easier to reuse stuff, because if you know this component is just doing one task and I want to reuse it, then you just reuse it. But if this component has 2 or 3 tasks and they are somehow intermingled with each other, then I don't know if I can call it from here because the situation is not exactly the same, and then you start copying and pasting code. And we don't want to copy and paste code, we want to reuse implementations. It also should lead to better maintainability. Code, you should have a much clearer idea about where a certain function is implemented, and it should be implemented only once and not 3 times all over again. I've had very often the situation in projects where we want to modernize something, and we were looking for how is a certain feature implemented in the existing application, the legacy application. And then the response was, yeah, a bit is here, a bit is there, a bit is there, and there's some redundancy. So the same code overwritten right, that's okay if it's redundant. But yeah, it does behave a little bit different here than it does there. That's bad, because then you, as somebody who doesn't have 20 or 30 years of history with that application, you cannot decide which is the right one or which is the right one in which situation. So that are things that we want to avoid. Then the open-close principle. So software entities, whether they are classes, modules, or functions, you should design them so that they're open for extension but closed for modification. That means you want to extend functionality of a class or of a method without changing the source code of that method. That's what that means. And there are many design patterns to facilitate that. One is the Decorator Pattern. And generally that's also something that in agile development is very helpful. You have code, maybe business entity that needs to call into a validation function, and at the beginning you only know 10% of the validation rules, but you want to start building screens. So you build screens against this business entity, and yes, at the beginning not all fields are validated, but then independent from writing on the screen, you can extend the validation. So one of these patterns is the Decorator Pattern. For the Decorator Pattern, and this is the example of the OpenEdge HTTP client that I used this morning also for the error handling. Progress, Peter Judge was one of the guys you can thank or blame for that, has designed it in a way that using the Decorator Pattern you can write your own class that can sit on top of that in a way that code that uses the HTTP client transparently calls through the decorator into the HTTP client without knowing that it's even there. They should both behave the same way. You can add things, you shouldn't alter the core behavior. And that is a very good example. So Progress publishes the source code of the HTTP client, so I could have changed the source code, but I didn't want to. I mean, with every service pack, Progress is going to make it better, the HTTP client. So that's why it would be a bad thing. And the same could apply to business entities and so on and so on. Liskov substitution is a little bit more abstract. It's not actually something that tells you how to write single methods or describe how you should design anything in a class. It's more like a behavioral pattern, like what is expected of two classes that inherit from the same base class. It means if you have, again, the business entity, and you have a customer and an order business entity, in either of the implementations, you should not abuse a method which is there, which you know is being called in a certain workflow, like maybe save changes, to do something which hasn't to do anything with save changes. So when you have this save changes method in a business entity, then you should keep to the expectation that this only validates and writes data for that table to the database. It should not actually start other processes with maybe creating invoice or whatever. That should not be in the context of save changes of a business entity, because that could cause unexpected side effects that could go wrong at a certain point. The interface degradation principle, in short, means rather than having few interfaces with many methods, have many interfaces with few methods. If you have one interface with 40 methods, because every now and then you may call here and there and there and there, then it just limits your flexibility in writing this class. You always have to then provide a class that implements all of this. And very often this leads to implementations where you have empty methods that just throw a not implemented exception. So that's actually not what you want to do. So dependency inversion is when you write code, you should depend as less as possible on specific implementations. So you should always code against interfaces or abstract base classes. But usually interfaces are the better choice. You should only very rarely, actually you should think of, if I use a new keyword in an actual class, I should always have a good excuse for that. There may be excuses. Maybe you have your implementation is in two classes and you say these are really tightly coupled and I don't want to swap out anything here, then there may be excuses for that. So this should not be like a law, it's more like a recommendation. But every new would be suspicious based on dependency inversion. I'm going to show you what you could use instead of that so that you can provide configuration for that. And it's actually as well factories or injection of references or services or whatsoever. So that's where factories come into play. So factories are classes that have the responsibility of creating object instances. So there we have single responsibility. So I've just said, well, if your object would be validating, and for that it needs a helper object, then creating the instance of that helper object would be seen as a second responsibility. So with that, you would be violating the single responsibility. And understanding what a single responsibility is, that is the crux. That is the most difficult thing. And probably when I ever retire, I will still not have a clear definition of where do you cut responsibilities. And that's probably also a lot of personal preferences there. But in this context, we say, well, creating an instance of a helper object is another responsibility. So you should have a specialized object for that, and that's a factory. So they should know how to create object instances. You may make that based on configuration. Configuration can also be source code. So you could have a class that knows the customer that's currently being used in, or the tenant, the login company, and based on that it creates price calculation routine A or price calculation routine B. So if you know you only have very few of those, it can be a case block. I mean, it makes more sense to have that in some form of configuration, and we use for these forms typically XML files. We use in our framework JSON files for newer configuration, but for the stuff that we already had in Open-Edge 10, that's mostly XML based because the JSON support was not yet that good in Open-Edge in version 10 than it is in 11 and 12. And there are millions of ways, well, many ways of implementing factories. we have a factory service. And I'll talk about what services are in a couple of minutes. And that is an object where we say create object. I want to have an object instance. I could have also named the method new, because that's actually the replacement for new. And I pass a type to it. And the type that I pass to this is typically an interface. Could also be an enum. Could also be an actual class, but that would not make any sense. But we have not blocked the usage of classes there. So there I would say, create me an object of type I price calculation. I typically for interfaces, also there you see that I started with .NET. Java programmers don't give any decoration to interface names. They call the classes impl. But being a .NET influenced guy, my interfaces start with a capital I. And luckily, Progress thinks the same there. So the interfaces that we get either as part of the Progress client implementation as a 4GL implementation, or in the OpenEdge package as ABL code, they also all start with a capital I. So I ask a factory, give me an object of type I whatever, and it returns me an instance or an error if it doesn't know how to create it. And that's my alternative to new. We have in few places where it's very specific to a certain typically customization demand. We have factory methods. That is, somewhere in a base class we have a method called new whatever, new query string, for instance. That's the place where we new in our data access class is the class that actually does the query manipulation. And we know that some customers have custom variants of that, and so we provide a factory method, and I'll show that in a second. That's what we used for you guys last week, 2 weeks ago. And abstract factories, that's something where I'll skim through some of the Progress code. That's what Peter and his colleagues have implemented for the various builders of the HTTP client. But generally, try to avoid direct usage of the new keyword. So, for a very simple example, so it starts with an XML file, and because I'm lazy, the XML file is a temp table written to XML. And I have the factory type, so that is what a consumer would be asking for, the iCustomer validator here. And an instance type, that is the type of the instance that will be returned. We do have a definition there of aliases. So if for different places in the application I need different types, maybe different customer categories or whatever of the customer validator, then the factory alias could be used for that purpose. It's a character value. In this case, it's left out. In my simple.p file, which is not using any framework bootstrap or whatsoever, I'm creating the instance of the factory, and that's what usually would be happening when the application starts. So you usually don't see these two pieces in one .p file. So it creates an instance of the factory, and I load the factory definition from XML. So and then I need an instance. So instead of saying O validator equals new customer validator, I'm asking the factory to create an instance based on the interface. So in starting, I think 11.4 or 3 or 4, the getClass function provides a progress.long.class reference to whatever you provide there based on strong typing. Before that, so in 10.2b and the early version 11s, you had to use progress.lang.class :getClass, and it would only be validated at runtime. So this is compile time validated. So this returns me the reference to that object. So when I execute that, no, where is it? So the type name, so I'm asking for iCustomer validator, but what I get in return is demo factory customer validator. So, and if there would be a second one, so I just create a copy of it. And I change the config file. Why doesn't it compile? So I've just provided a second instance. I've just changed the config file, nothing else, and I rerun the procedure. I'm getting now the other instance. So that's why the procedure itself that consumes either of these two validator objects doesn't know it, doesn't need to know it, shouldn't know about it. So that's what you do with factories. So if we look into our factory, it's actually very trivial to build that. We do have a temp table where we keep track of registered factories, where we have a progress-lang object and an instance type as temp table fields that are actually class references, but unfortunately the only object type field that we can have in temp table is progress-lang object. So, but that's where we keep track of the interfaces. So, and then in the create object method, create instance method, I need to find the right one. At the end of the day, we're just making a dynamic new. Can be a bit more complicated because we can also provide parameters to the constructors there, but that's just the one place where we use all the dynamic methods of creating object instances. And I think as a component, yeah, well, it says 500 lines of code, 490. So it's really not a very complicated, complex component. So what Progress is using for the HTTP client, on the other end, is a bit more complicated. They're implementing a couple of patterns there. They're using a builder pattern with fluent syntax that allows us to call from one reference into another one, and at the end we're getting the object that we actually want. So I want a client, and I'm asking the client builder, build actually initializes the builder. I can set parameters that way, and at the end I get the reference to the client. And it's also using an abstract factory. So when we extend the HTTP client, we provide our own builder which inherits from this, and based on configuration, this code will then transparently use our builder to return our decorated client, and so on and so on. But if I look at the time, I don't think we're going to drive through that code now. Peter's happy? So services. The term service, it's one of these software architecture terms that's used for everything. So in service-oriented architectures, so for web services, for instance, a service is understood as a business activity, so something that a system can reply to with a defined outcome, with a specified outcome. That's actually already, that means something like contract, and interfaces are part of a contract. A service should be self-contained, so it should be able to do what it does in a single call and gives the response back. For the consumer, it should be a black box. Consumer should not be aware of the inner workings of the implementation, and it may be composed of other services, so a service can call into other services to do its actual task. So when we look at software architecture of components, then we usually have more like a definition like that. So they have a well-defined functionality, ideally documented. Services should implement a contract, and part of the contract is the interface type. maybe with preconditions, so things like when a service should not be executed and when it's executed with violating the preconditions, it would be throwing errors. There should be a well-known way of getting a reference to them, and service implementation should be swappable, just like things that you get from a factory. And a lot of that sounds very similar to the factory. And in fact, when the CCS service manager was defined, Marion was part of that, myself was part, Peter was part of that. Did we ever have more than 2 authors of the CCS in one room after 2016? Probably not. We defined the service manager as a component that manages the relationship between the abstraction, so the OO type name, and implementing an instance. And the CCS service manager actually combines the factory functionality and the service manager factory functionality, for our definition. And the difference for us is actually something that you get from the factory is always a new object, and the service is typically one object in the session that's reused. So a factory is used when the object might contain context, which is just a very short living duration. And the service manager would be something like the price calculation routine. You load it once and you can always do calls into it. So price calculation would be more of a service for me. Whereas maybe a part of validating a customer would be something that we create through the factory. We have an example of a service manager, and that's the source code that is available on GitHub. I have it in here. That is something that we did put together when the CCS was released. And our service manager works on an XML file, which is pretty much similar to the factory XML file. We reference the service type, which are typically interfaces, and then an implementation. I think by some of the class name you can guess how old these examples were. But what we have implemented here is we have implemented full transparency over the fact where the results of the 2016 Soccer World Cup came from. We had an implementation that was getting it through a web service, and we had an implementation that was getting it through a Progress database. And the only difference for the application is in these 2 service definition files, whether we load the left one or the right one at the startup. The interface types are the same, the implementation types are not the same. So that demos that it's swappable. So the online is doing web service calls. I would not expect maybe this still, but it's not, the purpose of this is not to actually get soccer results, it's of showing the principle. And all the code that consumes it, after the application has been launched, and during the launch we load either of the service definitions Where's it going on? What's in the service manager? The initialization of the service manager, we look for the session startup parameter, then we find the XML file, read that into a temp table, and based on that we're able to create these service instances when they're needed for the first time. And that then opens the question when to use what. So both are tools to provide dependency inversion. Factory, we use it typically to return an individual instance to the caller. So for one-time use, like Progress did with the HTTP request and client. That also means you could be preparing multiple HTTP requests in parallel. With services, when you only have one instance, you cannot set them up for two calls that should be happening in the sequence. You would have to do one request, one call, next request, next call. With things that you get from the factory, you can do that in parallel. And the service manager typically returns a shared instance, scope to the session or scope to an app server request. The consumer should not care about how long that lives. When you get something from the factory, it's the consumer's responsibility to decide if the object is no longer needed. So then, again, one of these patterns, that's also in the way that we have implemented here more from the .NET world, the service creator. So the service manager, like the factory, is very limited in its capabilities of creating the new object because it's a general purpose component. It cannot use specialized configuration or maybe even in the sample that I'm showing you in a second, show a login dialog to the user. Or read in a database configuration instruction. Read from a database things like I need maybe for an active MQ queue, I need to know the queue name or the host name where the queue is and whatsoever. So with the service creator pattern, you can implement that in a way that is 100% transparent to the consumer. And that could, and that's the example that I have prepared, include presenting a login dialog. So I stay with the sample of doing calls into Jira. So I do have here an example file that, again, and that would be the start of the session, so not usually within the application. We have an include file in which we hide the call into the service manager to get an instance. And if we look into that include file, it basically calls in our service container the get service method. And the reason why an include file is quite handy, we want to ask for an object of a certain type, the interface there. And the result of that, I want to cast to it to avoid always have to write it like that. We've boxed that in an include file, but I could also do it like that. It will just work fine. Should work fine. I'm missing a dot. That's a very good thing, yeah. So other OO languages do have a concept that works around that. In C#, for instance, the way it would look like would be Jira equals service container get service of like that. That would be a generic method. So on the fly, the C# compiler knows, okay, I'm passing this argument to the method, and the argument that I pass into the method actually changes the return type. The ABL unfortunately does not have any form of generic methods. So the next time you meet an OpenEdge product manager, twist their arms, because that's really a very, very important feature to have. So, but what do we do here with the service creator? So within the service XML file, I'm registering for the Jira client service, the Jira client creator. Nothing special, so that could actually be an implementation of the Jira client interface, but in fact it is not. When we use the service creator pattern, then our service container knows that the first time somebody asks for the Jira client service, and the object which is registered as the implementation actually does not implement the interface itself, but implements the iService creator, then the service manager, as the central piece of infrastructure, knows, okay, then I know that this is not actually the object to be returned, but this object can create the instance that should be returned. And it does that by calling into a create instance method of the service creator. So what we do here is I've implemented a quick login dialog. So we have a credentials object. So that's an object that has a username and a password property. So I create an instance of that. With these, more or less 3 lines, I'm defining a login dialog on the fly. So I say for the username property, I want to have a text box with a label username, and for the password, I want to have a text box labeled password. And I extend the definition by saying it should be having a password character. And then I run a general purpose input helper that gets the object that should receive the value and this list of property specifications, and that's implementing a whole dialog. And when I get the object back, then I'm storing the credentials object also in the service manager so that it's generally accessible. And when I run this now, and again, the consumer doesn't know anything of that. The consumer just asks for an instance of the Jira client service. And when I execute that, so I see the message before requesting the Jira instance. And now I see the login dialog, and that's coming out of the service creator. And then I log in. Then I'm getting the error message from our customization of the HTTP client. So first we're customizing or creating an alternative implementation of the Jira client. No, we're not. We're using the standard implementation of our Jira client service, but before we create it, we make sure that we have the login dialog through the service creator. So the service manager, there, all that is special there is, and we can look into the service container implementation. So all that does is somewhere in the code that's returning the instance, it's checking whether the service that is actually part of the pool of services that's maintained by the service manager, if that's implementing the service creator interface. Then we call into the create service method of that one, and that is the object that we return, and we're not returning the service itself. So it's, again, not a lot of code that needs to be written for that, but very, very powerful. So inheritance, I think it's one of these concepts that people start using very quickly. You start writing a base class. The base class may just be intended to be a base class, or it could also be useful by itself. Inheritance is done using the inherits keyword in the language. Inherits, if you don't use the inherits, there's always a base class, so the compiler will then replace the lack of an inherit statement with inheriting from progress.lang.object. So every object is a child of progress.lang object. So and that actually means, well, you're creating a shared base type. So under the, or shared type, under the base class and all the objects that inherit from it, they could all be referenced by a variable defined of the base class type. So if you need to have general purpose code, like I had earlier, the validation of something or calculation of prices, and maybe you think they should all share some behaviors, and you could be implementing that based on a on an abstract base class. But when you then reference either of them, you would be referencing them not by its specific variable, because then you would need to know the number of different implementations when you define specific variables. You would use the shared type, which is the base class, and define a variable against that. But that should then remind you of the expectation of the Liskov substitution principle, that the methods which are part of the base class, they should behave in the same way. I mean, they implement different specifics, but not really alter the original behavior, because then this assumption of the behavior would no longer be true. And you actually inherit the behavior, so the code in the base class. So that's something that you could be using pretty much like an include file. So like that, well, all business entities that we develop, they may inherit from the same base class. We're not enforcing that, but they may inherit from the same base class. So they will share a common behavior and the same interface. So interface means the collection of public methods and properties. So that's the consequence of inheritance. So during inheritance, you can override methods. ABL does not have, and I hope that will change soon, the ability to override properties. Only exception there are properties which are abstract in the base class. Events can be inherited, but that means that the subscription to these events can be inherited, but the publishing of events is always private, so only the base class that defines an event can actually raise it. The destructor is inherited and implicitly overwritten. Each class can only have a single destructor that's executed when an object should be destroyed. Constructors are not inherited. So if a base class has a constructor with parameters, and the child class should have the same parameters in the constructor, you need to implement a specific constructor for that purpose that basically passes through these parameters. I'm seeing I'm doing really bad on the time here.
What do you mean by overriding the destructor is overriding? What do you mean by that?
Well, the base class destructor is called and your class destructor is called. So you're not hiding the destructor. They're all called without calling into the super destructor. The thing with the constructor is something which is important to know. In our business entity base class, we pass a handle of a data set of the actual data set of the business entity into the base class. In the data access class, let's use that one. The constructor is expecting a parameter and is actually passing it through to the base class. So that's needed. If I wouldn't be implementing the constructor in the child class, then the only constructor which would be there would be the constructor, the default constructor without any parameter, the one which is always there. So that's why this inheritance with constructors or not being inherited actually is something that you need to keep an eye on. So you can have abstract members. They can be very useful. The base class knows about them. It doesn't have to create an ugly, empty implementation of them. And the compiler then enforces that these methods are there. So what that means is, in our business entity base class, which is an abstract class, we do have a method called validate data. And because I'm using the abstract keyword, I'm not creating a method block. It's more like a statement. It ends with a period. And because of that, the customer business entity will need to have the validate data method. It's enforced by the compiler. And if I would be renaming that, I'm getting a compile error. Well, one should not do the override, but being like that. At the end of the class, I'm now getting a compile error because then the compiler tells, hey, the base class requires an implementation of validated data, and I'm at the last line of code, and you still haven't provided this. So, and what it's good for, that the business entity base class knows that it can call into this method. So it doesn't have an implementation. It says this object validate data, and because of the abstract nature of this method, it's calling into it in the child class. It's very useful if you have these kind of things where the base class provides like the main flow of operations and certain specific things that's the influence of the child class. That's where these abstract methods become very handy. So that was this.
Mike?
Just a question from the chat on factories. So from Ivan, on the factory topic, would you say executing external API services requires a factory, e.g. REST sharp?
Sorry, can you repeat that?
On the factory topic, would you say that executing external API services requires a factory, so like REST sharp, the example?
Well, a factory or a service. So my tendency is that external API is used constantly through your application, and the API implementation itself doesn't need to have any state, so it doesn't need to, you don't need to set up parameters in multiple calls, so you just do one call in and you get a result, like without Jira. Then I would do it as a service. But generally with all of these external things, factory or service would always be the way to go. Good, so I'm afraid I'm at the end of time, not at the end of slides. So are there any questions? Good, well then thanks for your time and have a nice afternoon. So who's next? Peter?